Hey guys, this is Alok and I hope you all are doing very well. So today we are going to solve one more Geeks for Geeks problem and part of the series which is also problem of the day. So let me tell you what problem statement is. Okay, the problem name is a largest subtree sum in a tree. So problem statement says that given a binary tree, the task is to find a subtree with maximum sum in the tree and return the sum. Okay, so just try to find the subtree which is having the maximum sum and return that sum. Okay, that's the only thing. So it is quite basic thing that everyone can understand, that we need to do some kind of traversal and we need to return the maximum sum that can be possible. Okay, so it is tagged hard. I don't think it should be hard tagged here. So anyways, so if you know recursion, if you know how to solve by using depth first search, so it is mm, like very easy for you. So for that you need to understand what DFS is. So if you don't know what DFS is, so highly recommend just try to learn DFS first, then come to this video and definitely gonna understand. Okay, so yeah, let me tell you. Like this one is a very simple case. Here you don't need to do anything, like it is all positive, so you need to return the sum of all the elements. Okay, traverse the tree anyhow and you need to return the final sum of the elements. That is gonna be our answer. Okay, so the main catch is here. So what you need to do, you need to like there is some negative elements too, so you need to avoid the negative elements, or with the element the subtrees having the negative elements or making the sum is negative, so you need to avoid that. So that's the catch, and the code is here. Like as you can see, this is the code. Let me tell you how this code is working. Okay, so let's take an example, which is, yeah, so this is the example by which I'm gonna try run this code. So initially this is, if there is no root node, then you need to return 0. So as here is no root node, so you need to return 0 here. So that is how he will conclude their sum as 0 plus 0 plus 4. Okay, he will gonna conclude and both will return 0, and this is how he will get the 4 sum and he will return their sum as 4. Okay, so that's why the base case is the here. So then you need to call for the left and right one. Okay, so start from this. You need to call from for the left and for the right. Okay, as I told you. So before that, let me tell you how we are going to store the sum. So initially we created that answer variable and set is at int max, means that, sorry, int min means that it is having the minimum value as possible. Okay, minimum value as integer can possible. Okay, so that if there is anything value which cannot, like if there is value something like minimum 1 minus 1, so it minus 1 still better than this value. Okay, that's why we put it here. So now we need to call DFS as root and answer should be there. So now DFS is going as the base case here and left right call is going. Now what you need to do, like you need to just left and root and right, as I told, left ka data plus root ka data plus right ka data you need to conclude, so that this cell and this cell, any of the cell is can able to conclude the sum. Okay, this is how we can conclude our sum, and the sum is gonna be returned. The sum is gonna be returned. Okay, whatever the sum we got, we need to return the sum. But before that, what we need to do, we need to update that sum in answer variable, so that we can have always the maximum answer. Similarly, so what we exactly did here, what is that, we did answer is equals to max of answer comma current is what, like whatever the sum we got right now. Okay, so we need to update the value. If it is the maximum sum, then we need to update. If it is not, then let the maximum one as it is. Okay, so then we need to return that current value. Okay, I hope you got it. So this is how it will gonna work, and it will return their value. Similarly, this is how this subtree is also gonna return their value, and this subtree is also gonna return their value. And if they still, like at this level, both of the trees are giving the positive value, then definitely gonna we will gonna consider this complete tree. Okay, so in this case we are we are going to accept like complete tree. We are going to sum all the tree elements. So this is how we end up with that positive solution. Yeah, so that was it for the solution. Let me try to run this, and definitely it is gonna run. I checked it already. Yeah, it is working. Let's try to tell you about the time complexity thing. Okay, so the time complexity, as you can see that we are traversing all the elements. all the elements at least once. So it cannot be less than n. Okay, so yeah, that is it. Like it is having the time complexity as O big O of n, but as it mentioned over here, like 10 to the 5, we can still solve it in L log n, but as it mentioned, we need to solve it O of n only. So that's why we did it. This is completely optional. There is this like text that we are having. Okay, so that is it for this video. I hope you like it. If you really like it, then please like this video. Thanks for watching. Meet you in the next video.